Donetsk region, eastern Ukraine. A Russian logistics convoy is moving. Trucks, fuel, ammunition. The drivers know they are targets. They keep moving because stopping is worse. A parked target is an easy target. They do not know that 50 miles away, a Ukrainian crew has already entered their coordinates into a computer. The crew does not need to see the convoy. They do not need to be close. They press a button and walk away. The rocket is already in the air. This is the M142 HIMARS, High Mobility Artillery Rocket System. It is a truck. It weighs about 16 tons. It carries 6 rockets loaded in a single pod. Each rocket weighs 300 pounds, travels at over 1,800 miles per hour, and lands within meters of its programmed target. Meters, not hundreds of meters, not a general area. The specific point the crew entered into the computer. The convoy has no warning. Modern air defense systems can sometimes detect incoming artillery. HIMARS rockets fly differently. They are faster, higher, and guided. By the time radar picks up the signature, the impact is seconds away. The drivers cannot outrun it. Nobody can. For most of modern military history, long-range artillery was powerful but imprecise. Commanders compensated by firing large volumes of shells. More rounds meant a higher chance of a hit. This approach consumed enormous amounts of ammunition and took time to set up. HIMARS changed the calculation completely. The system fires GPS-guided rockets. GPS uses satellites orbiting Earth to calculate an exact position on the ground. The rocket follows that position all the way to impact. The circular error probable, the military term for average accuracy, is under 10 meters. 10 meters, the length of a small bus. Traditional artillery has a circular error probable of 100 to 300 meters depending on range and conditions. The difference between 10 meters and 300 meters is the difference between destroying a specific building and destroying a city block hoping the building was somewhere in it. HIMARS also shoots and moves. The crew fires its rockets in under 40 seconds, then drives away before enemy counter-battery radar can calculate where the rockets came from and fire back. Counter-battery radar is a system that tracks an incoming shell or rocket in flight and works backward to find the launch point. HIMARS is designed to be gone before that process completes. Russian artillery crews have tried to target HIMARS launchers throughout the conflict. Ukraine has lost very few confirmed HIMARS units to Russian counter-battery fire. The system's speed and mobility are a core part of why. Since Ukraine received its first HIMARS systems in June 2022, the documented impact on Russian logistics has been significant. Ammunition depots are the first category. An ammunition depot is a storage facility where large quantities of shells, rockets, and explosives are kept. These facilities are typically large, hard to hide, and require significant infrastructure. Moving them is slow and complicated. Russian depots were positioned well within their own lines, far enough back that Ukrainian artillery could not reach them. HIMARS changed the safe distance. Overnight, facilities that were considered safely out of range became viable targets. Ukrainian forces struck multiple confirmed depot locations in 2022 and 2023, producing large secondary explosions. Secondary explosions happen when stored ammunition inside a struck facility detonates visible from miles away and documented extensively in satellite imagery. The second category is bridges and river crossings. Russia's supply lines in southern and eastern Ukraine depend on crossing specific rivers. The Dnipro River in particular has several crossing points that Russian logistics convoys use regularly. HIMARS strikes on pontoon bridges, temporary bridges built for military use, and permanent bridge infrastructure disrupted resupply operations in ways that ground-based artillery had not been able to achieve. Russian forces responded by dispersing their supply depots. Dispersal means spreading material across many smaller locations instead of concentrating it in one place. This reduced the damage any single strike could do, but it also made the entire logistics system slower and more complicated to manage. Moving supplies across a dispersed network takes more vehicles, more fuel, and more time. The third category is command posts. A command post is a location where military commanders coordinate operations. They require communications equipment, power, and enough space for staff to work. They cannot be moved constantly. HIMARS strikes on confirmed command post locations have been documented throughout the conflict, forcing Russian commanders to operate from more mobile and less effective positions. Return to the footage from Klitschko, Donetsk region. The men on the ground, close combat, grenades through windows, basements cleared by hand. Every meter can test it. HIMARS operates at the other end. It never gets close. It does not need to. Russian soldiers in the field have adapted their behavior because of it. Documented changes include avoiding large gatherings of vehicles in open areas, shortening the time any unit spends in a fixed position, and relocating command structures more frequently. These are behavioral changes caused by a weapon system. The threat alone altered how an entire army operates in the field. Soldiers cannot run from a rocket traveling at 1,800 miles per hour. The response is to never be in one place long enough to be targeted. But constant movement degrades coordination. It exhausts crews. It burns fuel. It slows the pace of operations for the side that is being forced to move. This is the indirect effect. HIMARS does not need to destroy every target. It needs to make staying in one place dangerous enough that the opposing force never fully settles. A military that cannot consolidate cannot park its trucks, stock its depots, or hold its command posts in fixed locations fights at a permanent disadvantage. HIMARS is not a new concept. Precision-guided munitions have existed since the 1970s. What changed is the scale and availability of GPS targeting, the miniaturization of guidance systems, and the cost reduction that made it practical to put this capability on a standard military truck rather than an aircraft. Before systems like HIMARS, precision strikes required aircraft. Aircraft are expensive to operate, require pilots, and can be shot down. A HIMARS launcher costs approximately $5 million. A single F-35 fighter jet costs over $80 million. Both can deliver precision strikes. One requires a runway, a pilot, and a multi-million-dollar maintenance program. The other needs a truck driver and a 6-rocket pod. The military term for this is democratization of precision fire. It means precision capability that previously required the wealthiest and most technically advanced militaries is now available in a smaller, cheaper, more mobile package. Ukraine, a country defending against a significantly larger military, used HIMARS to reach targets its ground forces and aircraft could not. The system extended the range of what a defender could hold at risk. Holding something at risk means making it a viable target. When an ammunition depot 60 miles behind the front line is at risk, the entire operational planning process of the force that owns it must change. Other countries have observed this. As of 2025, over 20 nations operate HIMARS, or comparable precision rocket artillery systems. The lesson from the Ukraine conflict has been absorbed into military planning across Europe, the Pacific, and the Middle East. The men in Klitschko fight with grenades and small arms, clearing one building at a time. 50 miles back, a HIMARS crew eliminates the ammunition those buildings were being supplied from. Both actions are part of the same operation. One is visible, one is not. The rocket does not